Melander from Denmark, speaking to us about innovations in organic weed management. Bo is an associate professor in the Department of Agroecology at Arhus University in Denmark. His specialization is weed ecology and non-chemical weed management, including robotic weeders, which we'll hear about today. I met Bo when I was invited to present last June on our organic research at Arhus University. And after hearing Bo speak, I immediately invited him to share his expertise with us in the US. Later, I visited a farm that Bo recommended that was, using a farm droid robotic weeder that was solar powered. It was so cool. And I've been dreaming about owning one since. For this webinar, Bo will speak for about 40 minutes. Then I will read any questions you, the audience, have in the chat box. So at the bottom of your screen, you'll see a little pop-up button called chat. Please put your questions in there. We will only read questions that are in the chat box. We're not going to turn on any video or audio to save bandwidth. So once you put your questions in the chat and Bo has completed his presentation, I will read the questions to Bo. All right, Bo, I'll turn the screen over to you and welcome to the program.
Yes, thank you very much, Kathleen. And thank you for giving me the opportunity to inform you about the advances that we have made in mechanical weed control technologies here in Northern Europe. I will not only speak about the new fancy technologies, but also about the more simple technologies. I hope you can understand my Danish accent. I'll try to do my best to make it clear and understandable. Okay, I will focus on three situations: full width cultivation, intra-row cultivation, and intra-row cultivation, and the advances that we have made within those three situations. Let's move to this machine. This is a Treffler harrow. It's a German invention that came to the market, I think it was 3 or 4 years ago. And it has a lot of improvements compared to the previous weed harrows, which I think you should be aware of. This weed harrow has a very special, the tines on the weed harrow is attached to the mainframe in a special way. There's a system of springs that makes each tine working independently of the other tines. So, for example, it's quite suitable for weeding on ridges, as I have showed here on these photos. But you can also use it for more traditional weed harrowing purposes. And it's much better to run on more uneven soils than the previous one. So there are many advantages with this weed harrow. It's also more expensive than the previous ones, but nevertheless, I think it's worthwhile taking a look on it. And I think it's sold in the US now and in Canada as well. There is another machine I want to show you. It's also simple technology. It doesn't have a lot of GPS stuff or vision technology, but it's quite new. And it's the OptiWeeder. It's also made for weeding on ridges, especially potato ridges. And as you can see on the left-hand side photo, there is a set of knives at the front and in the middle that slides the sides of the ridges as well as the top. And on the rear of this weeding unit, you have two blades that re-establish the ridges, all made in one go or one pass. And the steering system is quite simple, as I said. It just follows the ridges. He has made several patents on this steering system. I cannot explain in details how it works, but it's quite effective, I think. And I have two videos here I would like to show you. The one on the left-hand side shows how it runs in a situation where the potatoes haven't emerged yet. So it's for pre-emergence weeding. And on the right-hand side, you see the same machine operating in a potato crop that has emerged. And as you can see, it runs with a fairly high speed, I think up to 15 to 16 kilometers per hour. Sorry, I don't know what that is in miles per hour, but for us, it's quite fast. One of the challenges at the moment is to make the machine wider, so to increase the capacity. They are working on it so it can treat more rows in one pass. Okay, here you have the video on the right-hand side where the machine is operating in an emerged potato crop. So maybe some of you saw that on the top there was some finger weeders running instead of knives. So you can change the tool on the machine from knife to finger weeders, which is more gentle to the potatoes when they have emerged. So I want here to show you some results that we have achieved from some field experiment we made on sand soil. The top diagram shows the weed biomass after treatment. We have the untreated, and then we have different strategies with those two machines, the Treffler harrow and the OptiWeeder. And then we have a herbicide, a control treatment. And as you can see, the reduction of weed biomasses following the mechanical treatments is quite amazing. We ended up with hardly any weeds left after the mechanical strategies. In the bottom diagram, you see the response of the potato biomass, which is a reflection of whether there has been any crop injuries or not. And as you can see, none of the strategies have injured the crop significantly. You can see the reference in this situation would be the herbicide treatment. You can see the untreated has a significant lower potato biomass, and that's because of all the weeds that were left in those plots that competed with the potatoes. I want you to pay attention to this strategy, which is the Treffler one. Here you can see what we did. Our first pass were made when the potato sprouts were 1 to 2 centimeters long. And so that means they still stays in the ridge. They haven't emerged yet. The second pass was made when the potato sprouts were 2 to 7 centimeters long. So I think at this stage, they are quite close to emerge. And then we ended the strategy with re-ridging of the ridges. So we didn't use the harrow for that purpose because it's not designed for that. So we just used a ridger. But as you can see, the result of this strategy was quite effective. Moving to this strategy with OptiWeeder, it's just one pass made at a strategic, very sensitive point. The potatoes had 2 to 4 unfolded leaves at the time of treatment, and the weeds had around 3 to 4 true leaves. And I told the manufacturer that I think the machine is so effective that it can still control weeds despite a size of 3 to 4 leaves. So, and as you can see, it turned out quite successfully because the other strategies contain more than one treatment. They had up to 2 or 3 treatments. And capacity is a big issue for the growers. They want high capacity, the Danish potato growers. So, okay, now I move to intra-row cultivation. That was the second situation I was mentioning on my first slide. Intra-row hoeing in cereals, small grain cereals, has become quite popular in Danish organic farming, and not only in the cereals but also in the pulses and the oilseed rapes, or the canola as you call them. And we now have very good camera steerings to steer the hose accurately, with no need for an extra person on the rear of the machine to do the steering task. And as you can see here on the right hand side, I have a small video from a big organic farm in here in Denmark. The farm manager is a very innovative guy. He takes up all the new fancy technology, and he has a Garford intra-row hoe with camera steering here, and it works actually quite well. Here he is inter-row hoeing his peas. And as you can see, there is some covering of the pea plants with soil, but they can tolerate it as long as you're not is undercutting the pea plants. You're just throwing some soils into the rows. That will cover some of the weeds growing in the rows or in the crop line. If you look here on this diagram, it illustrates the principles of hoeing, or the efficacy of hoeing. It's much easier to achieve high weed control efficacy with a hoe as compared to a weed harrow, because as weeds evolve, become larger, they also become more difficult to control. And therefore timing, especially with the weed harrow, is crucial in order to get a good result. With the hoe, you have far more flexibility in terms of timing. Of course, the bigger the weeds will be at the time of treatment, the more likely it will be that you will be less successful with your weeding. What we have done in recent years is to, first of all, improve the steering accuracy with the vision technology, but we have also tried to improve hoe share performance, or the sweep, as you Americans call it. The hoe share performance at early crop growth stages. And we have made this shank and sweep design, as you see it here. We have designed a new sweep for early cultivation so that we don't throw too much soils into the crop line of cereals, because that could injure them too much. We have also changed, as you can see, the shank design to make it much more stiffer, because when the vision technology or the steering technology becomes more and more accurate, the requirements for the shank and the sweeps also increases. Especially there's a lot of requirement of stiffness of this in order to fully utilize the potential of the steering technology. Now I move to automated intra-row cultivation, which came up. I think the first machines came to the market in, well, that is probably 15, 20 years ago. There was a manufacturer here in Denmark called Frank Poulsen Engineering. He came up with a machine useful for transplants. In the beginning, they had a relatively simple vision technology that was able to create binary images of raw images. And with this binary images, they were able to locate or identify crop plants if they were clearly different from the weeds, and if there wasn't too many weeds, if weediness was too high or too big, that would disturb the whole picture. So they need a clear contrast between crop plants and weed plants, and that is often present in a transplanted crop, because you transplant into a black soil. And when the weeds eventually start to emerge again, they will be very small and very different from the big transplants. So this system worked actually quite nice in transplanting crop, and other solution came up as well, not only the Frank Paulsen machine, but also the Stegete in the Netherlands and the Ferrari from, I think was it from France? Yeah, there are several solutions. And I think he also sold a lot of machines to California, especially to the lettuce growers in California. With this vision technology, it could do a relatively nice job. But if you run into a situation like this one, this is actually a row crop meant for producing seeds. It's a horticultural crop and it's for seed production. And I think the grower in this situation wanted to conduct inter-row cultivation with a camera steered hoe. But in such a situation, they may have difficulties detecting the rows, because as you can see, there's a lot of weeds. It's a grass weed that is growing into the inter-row space. And when you run into this situation, this is it should have been a sugar beet crop. And you can find sugar beets, but you cannot really see the rows. In this situation, none of the older vision technologies based on identifying green spots, let's call it that, they cannot operate in such a situation. It's impossible. I have made some close-up photos here of the sugar beet plants, and you can see I have encircled the sugar beet plants, and this is a very weedy situation. But this has now changed. The manufacturers have adopted the technology of artificial intelligence, and it's amazing what they can do now. Frank Paulsen Engineering has sent me these photos to illustrate how well artificial intelligence and machine learning can handle different crop weed situations. Here you have a situation with sugar beet plants growing together with weeds where weed density is moderate, I would say, low to moderate. And you can see in the middle, and the purple dots show where the center of the sugar beet plants are located. And on the right-hand side, you see a heat map, and that shows the probability that it's actually a sugar beet plant that the software has detected.
Well, I'm hearing it on another computer.
Can you mute that, Olivia, please? Everyone mute your speakers. Go ahead, Bo.
Yeah, okay. On the right-hand side, that's another situation, crop weed situation. Again, it's sugar beets. And as you can see, in most cases, the technology is capable of finding the crop plant. There is one here where it has used another color for framing the sugar beet plants, and that's where it's not so sure about whether it's a sugar beet plant or not. You can also see it on the heat map on the right-hand side. Let's move to a much more difficult situation. Here on the left-hand side, again, you have the sugar beet plants, and you have a high weed pressure. It could be an organic grower, for example. We have organic growers in Denmark that have up to 1,000 weeds per square meter. So that's quite a lot. But if you look here on the right-hand side, especially, it's still amazing how relatively well the detection technology can identify the sugar beet plants, despite the high number of weeds. And this is all a result of training the software. They have how would you say, they have tested the vision tech or the artificial intelligence on a lot of different films and photos of sugar beet plants to make it as robust as possible. And they are now at a stage where they have started to sell it for commercial growers. But they're not the only one on the market. And I have a video here. I think now it's 2 or 3 years old, but still it shows quite nicely how well this technology can operate in a direct sown sugar beet crops. You have to understand that when we move to the direct sown crops, often weeds and crops are emerging simultaneously, and that can make it much more difficult for the detection technology to recognize the crop plants. But still, as you can see here, this video is from a organic grower of sugar beet plants, and and of course he keeps improving the technology. So as I said, this is 2 or 3 years old, so now I'm pretty sure that it looks even better now if he with the technology he has at the moment and with the upgrades that he has made. Okay, let's move on. This is another way of weeding. He's also working, this manufacturer is also working on a thermal device. So instead of using mechanical weeding, he also has the idea of trying to control the weeds through heating. And he works on flame weeding, and he has made a prototype which looks quite nice, I think, but it hasn't been commercialized yet. But the reason why he's interested in flame weeding is that you are not disturbing the soil, so you're not stimulating new weed seeds to germinate. So you, in principle, you shouldn't have much re-establishment of weeds after thermal treatment. Here you can see he is weeding around a sugar beet plant. It's actually an array of burners that are turned off every time they pass a sugar beet plant that has been detected by the camera. However, there is still some challenges with this approach. It's quite sensitive to crosswinds, and there is still some challenges with flaming close to the crop plants, and so I don't think he has made that much progress in recent years with this device, but I don't think he has given it up. And I think you may see future robotic weeders that has taken up this idea of thermal weeding. Okay, now we move to the farm droid, which Kathleen saw in Jylland in Denmark while she was here. And it's for sure, it's a very futuristic machine. It has a completely autonomous operation. It follows a route plan, and it's driven by solar energy. There is a solar panel on the top that charges some batteries, and it can actually run 24 hours a day. So it can work round the clock. And it's based on geolocation of each crop seeds. That means it seeds the crop and it also weeds the crop. So it utilizes the GPS position of every single crop seed. So it's actually creating a seed map after seeding. And when it revisits the field for weeding purposes, it utilizes this information that it created during sowing. So subsequent mechanical weeding is definitely based on expected crop plant establishment. So in principle, they can start off weeding the crop very early, in principle, before the crop has actually emerged. And that can be relevant if you have very weedy situations with high weed pressure. In this photo here, the farm droid is actually just performing or conducting intra-row cultivation. So they have switched off the intra-row weeding. So it's actually in a canola crop. One of the drawbacks about this system based on GPS is that it always expects a crop to be there. So if the crop seed doesn't germinate, you have a hole there. You have a hole that is not the hole in the field that is not weeded, because the machine thinks there is a crop plant present, but it may not be the case if the crop seed hasn't germinated. And they are now working on a solution to handle this problem. And I think the next generations of this machine will be equipped by vision technology as well. And that will, of course, make them more expensive. They're quite expensive at the moment. And they have a very low working capacity. I think you can get a imagination of that in this small video here. It runs very slowly, and it has to go both up and down. It has to weed from both sides of the crop rows to get a decent result. But they have improved the machine a lot since I made this video. I think this video is 2 or 3 years old, and they keep improving the machine. So I think nowadays it looks even better. But one of the criticisms of the machines is that, as I said, the work rates are very low. And for a big enterprise, you will need more than 1 unit. You may need up to 4 or 5 units. And with the current cost of just 1 unit, it's becoming very expensive. Nevertheless, they're very successful in selling this machine. They have increased their factories several times to meet the market demands, and as I said, they're selling quite a lot of units across Europe. So I'm a little bit surprised about that, because I still think there is room for a lot of improvements. One of the big issues about automated intra-row weed control is the close to crop area. I think you can imagine that there is a limit as how close you can go to the center of the crop plants. This is an onion transplant. And here on the right-hand side, you see a small wheat plant. It's actually a lamb squatters growing there. And it's growing too close to the onion transplant for the automated weeding technology to actually remove it without removing the transplant. So in this situation, you will leave this weed behind after a weed treatment or weeding treatment. And here I have made a circle illustrating the area which this machine cannot really target. And leaving such a weed plant behind means that it will grow without any suppression from the onion plants. Onions have no weed competition at all. So they're very vulnerable to weed competition. And that is still an issue that needs to be resolved. Currently, the only option is hand weeding. So you need labor to remove those weeds. Not all crops have the same demand for removing the weeds in the close to crop area. This is actually from a competition study that we made some years ago. We grow onions in different untreated zones around, we grow weeds in onions in different untreated zones around the onion transplants. And the x-axis illustrates the size of the untreated zone around the onion plants. And the bigger this size, the more weeds were actually growing and competing with the onions. And as you can see, the yield losses are really great. up to 90%, and yield losses increase very rapidly as the untreated zone increases. However, in a crop like cabbage, for example, where you have far more competition from the cabbage plant, you're actually allowed to leave the weeds untreated in a zone around each cabbage plant, in a zone with a radius of 2 centimeters. So there's not the same requirement for this complete weeding close to each individual crop plant. So in some cases, you don't need the same high level of weed control as you would do in crops that has no competitive ability like onions. Actually, Margaret, as I mentioned before, she did a study here with me in Denmark on the tolerance of sugar beet plants when you really go close to each crop plant. And well, there's a lot of numbers here, but all the circles show where we made a direct hit. So there was no distance from between the hoe sweep and the sugar beet plant. So it was, as I said, a direct hit. And of course, that would cause a yield loss. But as soon as we was just 1 centimeters and 2 and 3, 4 centimeters away from the center of each sugar beet plant, we did not injure the sugar beet plants. So that means, to us, it means that it's really a matter of accuracy. The more accurate you can make this automated weeding technology, the closer you should be able to weed, the closer to the crop plants you should be able to weed. Here you can see also when she did this experiment, when the sugar beet plants were very small, she didn't see any significant growth reduction, but she saw this phenomena of forking, as you can see here on the photo. So it's still not recommendable to make a direct hit. Yeah, here is a small video. I will end my presentation showing this small video. It's based on Margaret's work that we try to go even closer to the sugar beet plants that we have done previously to see whether the machine actually could do the job and whether we got any yield penalties, and of course also to assess how many weeds we were actually able to control. And here, this, as I show here with the 5 centimeters radius around the center of the sugar beet plant, that was the closest we could go without removing too many sugar beet plants. And we were actually able to remove, no, that's not, I'm not saying this correct. This was the counting circle. We try to go as close to the sugar beet plant as possible. And this circle with the 5 centimeters radius show the assessment area. And within this assessment area, we were able to remove 75% of the weeds growing within this circle, which is quite good, I think, because it's 5 centimeters is not much in terms of distance from the center of the sugar beet plants. And this is how it looked on the video. And as you can see, we actually go that close that we actually touch them slightly, the sugar beet plants, but we are not uprooting them. And in the end, they yielded the same as the control treatments. But whether the growers are willing to go that close, I'm not sure. I think they will be a little bit nervous about a setting where you are that close to the sugar beet plants. as we were in this situation. So I think we are trying to figure out how we are going to deal with this area close to each individual sugar beet plants. And this, of course, also applies to many other row crops. We just work on sugar beet plants as a how would you say, as a standard crop, but if it works for sugar beet plants, it's not difficult to implement it in other row crops as well. Yeah, I think that was my last word is about this chapter. I sent it to you, Kathleen, and it's open access, and a lot of the information that I have provided here can be found in this chapter. It's an update about not only the machines I have showed you here, but also many other aspects related to mechanical weed control in agricultural crops, both the ones that are broadcast zone as well as those that are established in rows. Yeah, I think was all from me. So if there is any questions.
All right. Thank you so much, Bo, for such an interesting talk. For the audience, please put your questions into the chat box and I'll read them to Bo. We have about 20 minutes for questions, so good time for discussions. I'll start reading you what's in the chat so far. Bo, Kurt wants to know the rigid shanks on the weed implements. Do they have any issues if the fields have rocks in them?
Yeah, they do. Mechanical weed control is difficult if you have rocks or too many stones. I have to admit that, especially bigger stones. And the Danish growers spend a lot of time, if they have stony fields, they spend a lot of time removing stones, or they simply decide not to grow sugar beets or vegetables where they have such difficulties. So that's a challenge, I admit that. And many of the organic growers having very stony fields, they have difficulties with implements for mechanical weed control. Either they break or they are not working properly. So yeah,
Continuing challenge.
it's a challenge. Yeah.
Couple questions about pricing, costs. I know you covered a lot of implements, machines. Is it possible to give different examples, like the RoboVator, how much that costs versus the Droid?
Yeah, the RoboVator, I can tell you, I think the Farm Droid for just one unit, that's something like if I say 150,000 US dollars, I think it's something like that. Yeah, you should expect that. Mm-hmm. That's at least the price in Denmark. But no, Denmark is a very pricey country. I have to say that. So they may market it at a lower price than US, for example. The RoboVator is somewhat cheaper, I think. It's also you need to attach it to the 3-point linkage of a tractor. So I recall that he sold a 31-row machine for a German lettuce grower at the cost of what would that be in dollars? It would be something like, if I say $400,000, something like that, I think. $350,000, $400,000 for a 3-row machine, 31-row machine. And that was a big lettuce grower in Germany, and he was very happy with the machine because he got rid of all the hassle with all the labor that he had to organize all the labor for hand weeding, to find the labor. That's another big issue. It's really hard to find the people who would do that kind of work. I know in the US you have benefit from a lot of Mexicans coming through to California, and we have had a lot of East Europeans coming to Denmark to do this tedious hand weeding work. But it's harder and harder to make them do it, and many of them go back to their home countries because salaries have increased in recent years in Eastern Europe as well. So growers are willing to spend a lot of money to get rid of the hassle with labor, handling labor, manual labor, and it's and then of course they can keep their crops clean, and especially lettuce they have very good experiences with automated intra-row weed control in lettuce.
So that connects to the next question about cost benefit analysis. Has anybody done any on that?
Yeah, they have, and I'm not so much into those figures. I had to admit I'm not an economist. I'm an agronomist, so I'm mostly interested in the possibilities with these tools and what they can do to the crop and how we can remove the weeds. But what I hear from the manufacturers is that they can sell all the machines they can produce. So there is a market for them, and as I said, growers really want to get rid of the hassle with the labor, and of course there is cost benefits calculations made on it, for sure there is. But you also have to understand that the wages are so high in Denmark, also the minimum wages. So the cost for sometimes you have to spend, for example, an onion crop, you may have to spend 500 to 600 hours per hectare for hand weeding. And then you have to multiply by the minimum salary that we have in Denmark. That's a lot of money, I can tell you. Mm-hmm. So you have room for paying for a very expensive machine if it can do the job for you.
Exactly. So for smaller growers, is there any sharing of equipment? See that a little bit here.
Yeah, the smaller growers, of course, they can hire a machine pool, or they can share a machine, and but some of the smaller growers, they are quite good at using the simpler tool, the ones without intelligence, the finger weeders, the torsion weeders, the weed harrows. If you really know how to handle these tools, you can go far. You can achieve quite a lot with these machines, but you need to be trained, and you cannot just let somebody else operate these machines unless they have some knowledge and training. With the intelligent weeders, it's much easier to replace the driver, because the driver just surveys the whole, or monitor the whole operation, but they really don't do anything. It's all done by itself. And nowadays the tractors are running without a driver. They follow GPS lines, and so it's quite amazing what has happened in recent years.
So what level of GPS accuracy is needed to run the automated?
Yeah, I think the differential GPS technology is down to 1 to 2 centimeters at the moment. So with that, you still need to have a safety distance to the crop plants of around, well, 3 to 4 centimeters, I would say. So you can weed pretty close to the crop plants. But the manufacturers of the vision technology, like Frank Paulsen Engineering, of course, they are advocating for the vision technology, because they say, well, we react according to what we actually see in the field. With the GPS, you're back to this expectation. You react according to what you expect to see, because it's based on the positioning of the crop seeds. Well, you can find arguments going both ways when it comes to the two technologies, but most of the machines operating on a commercial basis in Europe are based on vision technology. It's only the farm droid that make use of the GPS technology. at the moment.
So, Leah was asking, what's your row spacing on your cultivated peas and cereals?
Yeah, with the cereals and the peas, typically it's around 20 to 25 centimeters. I don't know what that would be in inches, but it's we normally call it double row spacing. So many small grain cereals in Denmark are grown at an inter-row spacing of just 12.5 centimeters. So when they prepare the crop for inter-row cultivation, they shut off every second hose on the sowing machine, and then they increase they maintain the seed rate, so they actually in principle get close to double crop density in the rows that remain. So with 25 centimeters, you have double crop density in the rows as compared to the normal row spacing with just 12.5 centimeters. And the idea is to ensure the yield by having enough crop plants per hectare, but also to increase the competition of the crop against the weeds that are not hit by the inter-row hoe. The inter-row hoe does not hit the plants, the weed plants that grow in the crop line, because of course, if it did so, it would also remove the crop. So therefore, they try to benefit on competition from a high crop stand, a dense crop stand. With peas, this is a little bit difficult because peas are not providing that much competition. But then they try other tactics. They try a false or stale seed bed before they seed the peas. They choose a land where they know the weed level is low to moderate. And then they grow the peas at the same inter-row space as the cereals, around 25 centimeters. But it's the video I show with the inter-row hoeing peas from that grower. He's very successful. He's a great grower. He really knows how to manage his crops, and it's amazing how weed free they are. And
Okay,
so,
Leah wrote in that 25 centimeters is 10 inches. And
yeah,
we plant ours 7 to 8, so that's a little wider than.
that's a little wider, yes. But of course, with this inter-row spacing, you need to have a reliable steering system. But if you, as you saw in the video, they can go quite fast with this camera system, and it steers accurately and reliably the ones that are available now on the market.
I definitely think that there's an opportunity to look at that in the US, because originally we believed that those small grains would tiller out and compete against weeds, but no, I think it might be helpful to do some inter-row cultivation on our small grains.
I want to add here that you can supplement the inter-row hoeing with weed harrowing. So you're still allowed to conduct a pre-emergence weed harrowing to get rid of the first flushes of weeds. And then you can follow up when the cereals have become more established. Let's say if they have 3 to 4 leaves and they're more anchored in the soil, you can follow up with gentle weed harrowing to get rid of more of the weeds growing in the crop line or in the rows. So that's what many growers do. They combine inter-row cultivation with weed harrowing, and they can make a very nice result. Weeding efficacy may go up to 80% or something like that. Sometimes even higher.
That's really good. I'm going to skip to this question about another piece of equipment. Michael O'Donnell's asking, do you have experience with the European-made electric weeder that sprays an electrolyte solution to increase conductivity?
Yeah, there is this machine I think it's made in German. It works on high voltage. So it runs over the field and has a generator that creates a very high voltage. And then you create this, I don't know exactly how it works, but it's mainly meant for vineyards. So They have mainly used it in vineyards to control the weeds growing between the rows of wine plants. But they have also tested it against potato haulm to stop the growth of potatoes as well. So, but to my knowledge, the energy demand is very high, and there is still some safety issues because the tension, the electric tension is very, very high, and it's dangerous for people. You cannot approach it; it will kill you if you get too close. So I think it's sold on a commercial basis, but I haven't seen any machine yet working here in Denmark. So
I mean,
so
the people here do use weed zappers. Michael's writing in that they use a weed zapper for weed escapes in soybean.
okay.
But I'm terrified of that machine, and I can't imagine making it more terrifying by spraying an electrolyte solution.
Yeah, that might be.
Uh,
But I don't have much experience with this technology yet. So
Okay, so there's a question about everything being relative, of course, as you mentioned about labor in Denmark, and also the price of produce in Denmark compared to here. So, I mean, that will determine a lot if people can afford these machines.
yeah,
So
for sure.
can you give us just an example? I was kind of shocked how expensive produce was in Denmark.
Yeah.
Like a head of lettuce, I don't
Yeah.
$5 or something like that. And
Yeah.
then what's your minimum wage there in Denmark?
The minimum wage in Denmark at the moment is around, what would it be now? It's around 130, 140 Danish kroner per hour. And in dollars, that would be something, I think the exchange rate now is 6 or something like that. So 5, 6, something like that. I think 6 is it. So that will be $20, $25 per hour. Yes.
Wow.
Yeah.
Yeah, here it's, I don't know. I pay
$20, I would say, per hour.
I paid 15, but I know I'm high. I think our minimum's probably $10.
Yeah. And then you have to be aware that on top of that, the employee has to pay for holiday. They get a certain percentage for holiday. We call it holiday money. They have to pay insurance, and yeah, it's quite costly for them.
But that's why Danes are so happy.
I don't know. Not the growers. when they have to pay these kind of salaries. So
Okay, so we only have 7 minutes, 6 minutes left, and I'm going to skip to the questions that relate to the equipment. Kurt wants to know any comments, suggestions on steering 3-point hitches. These hitches will be steered by camera vision? Question mark.
The camera vision is connected to a side shift. So there is a side shift between the hoe and the so the side shift is mounted on 3-point linkage of the tractor, and then the hoe is mounted on the side shift, hydraulic side shift. So that moves the hoe sideways. That's probably the most common actuator system associated with automatic steering. Yeah. The Frank Paulsen robotic weeder, the blades or the sweeps that went out and in while weeding in the row crops is driven by I think he calls it oil motor or oil engine. It's an actuator that is driven by hydraulic oil, and it's very robust. He's very much surprised by himself that he can make this in and out movement millions of times without any breakages or whatever. It's very robust, the system that he has chosen for his machine.
Okay, last question, just repeating that you're saying, we call it blind cultivating, when you just go over that emerged spring wheat with the harrow, and no damage to the crop, or at what stage would you stop?
Yeah, we the Danish growers, they tend to wait as much as possible. So when the cereals, the small grain cereals is 1 or 2 centimeters below the soil surface, they will run at the depth of, let's say, 2 centimeters, very superficially, but still it doesn't seem to cause any significant injuries on the crop or yield losses. So it's a very popular treatment. It's considered to be a basic treatment for all small grain cereals to do the blind cultivation, because you can be also in the peas. I have to mention that there is very important, and in maize and many other crops, it's only if you have vegetables, seeds of vegetables that are seeded very superficially, or if you have canola, for example, you have to be more careful, because then there is a risk of damaging the crops. But with the crops that are sown more deeply, that are seeded more deeply, well, you Americans, you say planted more deeply. When they're planted more deeply, the risk is much smaller, and you can go in with your blind cultivation. And as long as you just keep it at 2, maximum 3 centimeters depth, I would say 1 and 2 centimeters is good. But then you also need to make sure that you have prepared the land properly. You have an even soil surface, a nice seed bed, so that the harrow can operate properly. Preparation of your soil is important. Preparation of your land. If it's far too uneven, or if you have too many clods, or that may affect the outcome of your mechanical weeding for sure.
Right, I skipped that question, but definitely soil types would make a difference then.
Yeah, we have the best results on the lighter soils, I have to say. But having said that, if you try to recall the video I showed about intra-row cultivation in peas, that grower, he has very loamy soil, clay soil, I would say, and he tends to have a lot of clods, but it seems to be beneficial for him, because that very clod, if he can create an upper soil surface full of clods, he won't have much weed emergence, because it's not an environment for weeds to establish into. They don't like too cloddy soils. So he's very good at creating a seed bed where he have many clods on the very top, and further down he has a more a nicer seed bed with much smaller clods and a better contact between the crop seeds and the soil.
Excellent. Okay,
so experienced growers, they know these tactics. They know how to handle it.
A lot of trial and error, I'm sure.
Exactly, for sure.
All right, just to keep on time, we're going to sign off for now. I'd like to thank our webinar master, Olivia Hanlon, and her office at Farm, Food, and Enterprise Development at Iowa State for running the Innovations in Organic Ag podcast and webinar series. Thanks so much, Bo. We really appreciate all your work in organic weed management and taking the time to be on this webinar. And maybe we can get you to speak on organic weed management at our Iowa Organic Conference, November 27th in Iowa City.
Yeah, that would be quite interesting, I think.
Well, thanks,
sure.
everyone.
Yeah.
And we'll see you on our next webinar.
Yeah. Okay. Bye-bye.
Everybody's saying thank you. Very informative. Thanks so much. I'll leave on the chat for a minute here because people are writing in comments if you want to read it. So if you click on your chat, you can read. Thanks, everyone.
I'll leave now. Yeah. So that's fine. Okay.
All
Bye-bye.
right, thank you, Bo. Have a good day.